I'm going to do problem 155, minimum stack. So if you know how to use a stack data structure, it shouldn't be too tricky. But if you don't, I can see how that'd be a little bit of a stumbling block. Really, you have to just think about the operations that a stack would be designed to handle, which is of course last in, first out principles. You're thinking about accessing the last element within that stack array type data structure. The elements obviously held contiguously in memory. So about getting that done anyway. Stack. So we're going to initialize a stack, but we're also going to initialize a minimum stack as well. And this will allow us to essentially have those minimum operations handled kind of separately. And as far as space complexity goes, it would be a constant of the two different stacks that we create, or we could just remove that too, because it's a constant, so therefore there are two separate operations, not compounding space proportional to that input size. Let's see, self.stack.append. So we can actually just add this to the end of our main stack, and then we can just create a minimum value from our main value, and we can assess whether we want that to be added into our minimum stack, or whether we want to find the actual minimum value within that stack and obviously append that to the end. What do you want to do? I want to say actually it's self min stack, isn't it, since we're using classes. -1, because we want the last value if there is a min stack. So if self min stack, just gonna just chuck a ternary in there, else we can just put the value at the end. Then we can append that to the end. And that's essentially what's going to allow us to have our top value / get minimum value. Let's see, pop. So let's see, self.stack.pop. So we can remove the last element from our stack. That's going to be constant time operation as per last in, first out principle. Self.minimum stack, same thing. Top is actually going to be interesting. So that's actually going to be a return on our self.stack -1. So we're actually getting the last value. So it's like a little peak operation. So when I did valid parenthesis, or you do a problem like that, you typically want to take a look at the last value in that stack, because it's a constant time operation. There's really not much cost as far as having a quick little check and seeing if that value is what you're looking for. And then as far as minimum, we can just return the self.stack, well, our min stack, because that's what we were working towards with our push operation. So let's see, self.min stack -1, which should be the smallest value within that stack. And that should be it, to be honest. As far as what they're asking for, I read the question prior to, so save some time. And something is still wrong. What did I get wrong? List object is not callable. Because I was trying to call it, let's actually, how about we append it instead? That'd be nice, wouldn't it? Groovy. All good. See, I don't know if that comes in the blind 75 in terms of the main, like, core problems that need to be solved. But I think it's always good whenever, you know, data structures and algorithms being able to handle things like stacks and queues, they propagate upwards to real life system design challenges. So, you know, comparing the last element of something, reversing something, it might come up in like middleware, or the kind of mindset you would use for deconstructing a URL into specific parts, maybe accessing just the last element within that. So not quite the same as a string, but if you think strings and arrays, same in memory, but I think that's outside the scope of this problem anyway, but fuck it. That was minimum stack. The grind continues. That was day 15, so I don't even know what day I'm going to stop. Probably day 30, to be honest, because I've tortured myself enough and I have better things to do, believe it or not. So peace.